Hey guys, so let's go over the homework. Before watching this video, please make sure you have attempted each of the problems. And by attempt, I mean not just look at it and be like, oh, that's too hard and skip it. You shouldn't be doing that. We should be past that point by now. Okay, you should at least be trying to do some of the things that I showed you in the notes. If you're not doing that, then stop being stubborn and just buckle down and give it a shot. That's the only way you're gonna learn, guys, okay? All right, so number one, cosine x, tangent of x, we are simplifying. So I see tangent, and I know something about tangent. If we look back in our notes, which I still have right here, tangent is sine over cosine. So I'm going to replace tangent with that. So I have cosine of x times sine of x over cosine x. And hey, look at this. Cosines cancel. So all I have left is sine of x. That's as low as I can go. So that's the answer. How easy was that? Hopefully you guys gave that a shot. Number two, sine theta times cotangent theta. Well, cotangent is the reciprocal of tangent. It's cosine over sine. So sine theta, I'm going to replace cotangent with cosine theta over sine theta. And hey, look at that. Sines cancel. So all we have left is cosine theta. Number three, tangent of this symbol is called beta. It's also a Greek letter that they use to represent an angle. So tangent of beta, cosecant of beta. All right, I want to replace both of these because I know that tangent is sine over cosine. So sine of beta, it's like a capital B with a tail, over cosine of beta. Cosecant is 1 over sine, so times 1 over sine of beta. And hey, sines cancel. So all I have left is 1 over the cosine of beta. And you can leave it like this, or we know that cosine, or 1 over cosine is the same as secant. So either one of these answers is acceptable, okay? Number four, 1 minus sine squared over cosine of x. 1 minus sine squared should look highly familiar. 1 minus sine squared, right here. 1 minus sine squared is equal to cosine squared x. It's the big kahuna rearranged. So I'm going to replace 1 minus sine squared with cosine squared of x over cosine of x. Well, I have 2 cosines in the top, 1 cosine in the bottom. So this one is going to cancel out and take away one of those from the top. So all I have left is cosine of x. Number 5, I have sine squared theta over cosine theta plus cosine theta. So I'm going to have to add fractions and get a common denominator. So I'm going to have to multiply this one top and bottom by cosine theta, just like the example in the notes. And so let's rewrite this. I am going to have a common denominator in the bottom. It'll be cosine theta, so I can go ahead and write that. And I'm going to have sine squared theta plus cosine theta times cosine theta is cosine squared theta. And this should look highly familiar. It is the big kahuna identity. Sine squared x plus cosine squared x equals 1. So sine squared theta plus cosine squared theta equals 1. So 1 over cosine theta, so that's the answer. Or we know that 1 over cosine is the same as the secant of theta. So one or the other of those answers is acceptable. All right. Next, number 6, cosecant squared theta minus 1 times sine squared theta. Cosecant squared theta, minus 1, is that an identity? Well, if I take this identity and I subtract 1 from both sides, I will have cotangent squared x equals cosecant squared x minus 1. And right there I have cosecant squared theta minus 1. Okay, so I can replace cosecant squared theta minus 1 with cotangent squared theta. So I'm going to replace this with cotangent squared theta. And then cotangent is the same as cosine over sine. So I'm going to replace cotangent squared with cosine squared theta over sine squared theta. Okay, and whoops, got away from me. Sine squareds cancel. So all I have left is cosine squared theta. Boom shakalaka. Number 7, 1 plus tangent squared theta times secant squared theta. The 1 plus tangent squared theta seems highly familiar. Tangent squared x plus 1, 1 plus tangent squared theta. Hey, those are the same thing. So I can replace 1 plus tangent squared x with secant squared x. So I'm going to go ahead and circle that to kind of signify that I'm replacing it with secant squared x. Okay, now I have secant squared x times secant squared x. Well, secant squared times secant squared is now, what's your best guess, guys? Secant to the 4th of x. And that's it. Last one, number 8. Cotangent squared x minus cosecant squared x over tangent squared x minus secant squared x. Now both of these seem highly familiar. So let's look at the cotangent one first. So I'm going to be looking at this identity, looking for cotangent squared minus cosecant squared. So let's rearrange this. If I have cotangent squared minus cosecant squared, I have to subtract cosecant squared on both sides. But then I would also have to subtract that 1 from both sides. So I can replace cotangent squared minus cosecant squared with a negative 1. So I can replace this numerator with a negative 1. For the denominator now, let's look for something to replace tangent squared x minus secant squared x. Tangent squared x minus secant squared x. Okay, I think I can rearrange it. So if I subtract secant squared from both sides, I'll have tangent squared x minus secant squared x. But then I'd have to subtract that 1, so it will be on the other side and be a negative 1. Hey, so I can replace tangent squared x minus secant squared x with a negative 1. So I can replace this with a negative 1. All right, negative 1 over negative 1 equals 1. And that's it. I hope that helped. Hey, this video is under 10 minutes. How about that? Have a good one, you guys. See you in my next video.